We welcome you all the participants for the session too.
Kumarappan sir has joined, ma'am. Kumarappan sir will join soon, ma'am.
Dear participants, we welcome you for the session 2 now. A very good afternoon to one and all present here. I extend a warm welcome to you all for this faculty development program titled Global Warming and Impacts of Power Electronics Towards Green Technology. I find immense pleasure to introduce our speaker, Dr.N.Kumarappan, who is a present chairman of IEEE Madras section, a former head of the department and currently a professor with the Department of Electrical Engineering, Faculty of Engineering and Technology, Annamalai University. He is having 33 years of his academic experience to his credit as an educator and a researcher. He has published more than 130 international journals and conference papers, 44 international journal papers, 36 papers in IEEE Digital Library, 65 papers in various international conferences, and attended 9 national conferences. He received his graduate degree from Madurai Kamaraj University in 1982 and postgraduate degree from Annamalai University in 1989, PhD degree from College of Engineering, Gindi Campus, Anna University in 2004 under QIP Fellowship AICTE. Our speaker has received several awards such as IEEE NNS Outstanding Paper Travel Grant Award, Australia 2002, IEEE WCCI Outstanding Paper Travel Grant Award, Canada 2016, IEEE PES Student Program Award, USA 2003, IEEE CIS Madras Chapter Best Chapter Award 2017. He was also a recipient of Best Researcher Award, Annamalai University in the year 2018. And also, he coordinated more than 100 IEEE Madras section organized FDPs, workshops, technical meetings, and TISP programs. He was the organizer of the special session in IEEE WCCI 2010 Spain, IEEE WCCI 2016 Canada, IEEE WCCI 2018 Brazil, and the President Chair of IEEE MASCAN 2021. His current research interests include power system operation and control, electricity price forecasting, ESP transmission fault diagnosis, fact devices, power system reliability, artificial intelligence techniques, microgrid, distributed generation, and smart grid. He is a speaker, reviewer, and session chair for IEEE IDT UK international conferences and other international journals. We feel very privileged to have such a talented personality to share his knowledge and ideas for this session too. So, we are very happy to have you once again, sir, and request you to deliver your speech, sir. Thank you.
Thank you for the nice introduction. Now I move on to my topic, what I given as an introduction. Otherwise, what I given as an overview in the morning, in the morning inaugural session. The same thing is required to understand my title. Hybrid AC DC microgrid architecture. Initially, there is a fight between the scientists. Which kind of a grids to be selected? Is it a DC grid or AC grid? For not only the fight between the selection of DC and AC grid, it is really the fight between Edison and the Tesla. Therefore, finally, the Tesla he won. That's why it is decided the grid to be AC grid. Why it is so? Because power production also AC, transmission also AC, finally, and the receiving end also they utilized by as a load. For that also you require AC. Therefore, initially started with AC grid. But what happened now? The present day grid is not AC grid. It is changed. Now the present day grid is AC DC grid. So even in future, you can expect a DC grid. At that time, Edison may be won by his ideas. Till now, thousands of patents. No one has break his achievements. That is achievements reached by the Thomas Alva Edison. And therefore, based on that fight, we really gained a lot. And we got a number of inventions through them. Based on that, how we enjoy, even due to this pandemic, otherwise COVID, we are enjoying like anything. For that, the Edison or Thomas Alva Edison is a base. Because of him only, there is a number of things to find out in the electricity, as well as even the projector. Therefore, that two movie theater projector, as well as a number of things is find out by him. Because of that, we are enjoying like anything. Even with this pandemic, we are managing the life inside the house. But those people, one day they sacrifice this kind of an invention, they may not enjoy it. What all they find out, they may not enjoy it. But other kind of people only enjoy that technology. Therefore, the first kind of things here based on our topic is now the present day grid is AC/DC grid. It is not a AC grid. Now in future, you can even expect a DC grid. And if it is a AC/DC grid, initially started with the AC grid. The main thing is transmission loss. We always concentrate on the transmission loss because heavy loss due to transmission. Therefore, even compared to other countries, our transmission loss is more than that other countries. Not only that, compared to number of states within our country, some of the states are reduced the transmission loss better than us. Even on and all, the reduction of transmission loss is somewhat lower. But in Tamil Nadu, it is higher. Like that number of places, the state-wise also the transmission losses changes. And not only that, now the transmission.
Sir, mute. Sir, kindly unmute yourself, sir. Sir.
Right. From them we understand the present day grid is AC/DC grid. Once the present day grid is AC/DC grid, and in future even expect a DC grid. Based on the transmission loss, because compared to all other losses, the transmission loss is very high. How it is to be reduced? That is a question in front of us. For that, because of this, they're going on finding out number of invention, otherwise research. They do a wonderful research on that, how to be the transmission loss to be reduced. Once you concentrate on the AC, we only bother about the transmission losses. But once it becomes AC/DC grid, even compared to AC/DC grid wise, the transmission losses reduce like anything. Therefore, it reduced further. Therefore, always the preferable transmission, once somebody is asked, naturally the preferable transmission is DC. It is not AC. Therefore, because compared to AC/DC reduces the loss like anything. But that's why we require a DC grid. That's what we have expectation. But now at present level, we reached the AC/DC grid. How it is reached? Even the way of reaching the AC/DC grid, transmission wise, we can say we are one of the developed countries. We can say we are one of the developed country in the range of the transmission voltage wise. What is the way? In the morning class, morning introduction address, I told you there is a different kind of a things. Once you compare with electronics and electrical. Electronic side milli, this side is kilo. That side is micro, that side is mega, that side is nano, this side is giga. Therefore, now the nano wise we are going on very fastly. Because of that, the power consumption is reduced like anything. And not only that, the size going on reducing, not only a compact size, beyond the compact size going on reducing the electronic side, but in the electrical. But because of that, electronics become more popular. But electrical may not be popular, but development is equal to the electronics. Because we reached a micro, next level, we reached a kilo, we reached a mega, even we reached a giga. The giga, how we reached, that's what now I am explaining. Because the range of the transmission wise, the voltage wise, we reach the giga. That what is called as a giga. It started with high voltage transmission. Then it is extra high voltage. Above 400 to 765 kV is extra high voltage transmission. 765 to 1200, it's the ultra high voltage. Once you realize the 1200, we realize the giga. Therefore, that is we achieved in electrically. So that is the way we achieved. And now you immediately ask, is it achieved in India? We already achieved it. 1200 kV line is already erected. Similarly, 800 kV line, the DC side, that is also erected. That's why I'm telling we are one of the developed country, the range of the transmission voltage wise. Now we reach the AC and DC grid at the maximum level. AC wise 1200 ultra high voltage transmission, DC wise 800 kV. Between Agra and other place, they already erected a 800 kV DC line. Therefore, that way we are achieved like anything. The ultra high voltage transmission, a number of research it happened only at CPR at Hyderabad. They have done a wonderful research on that. Therefore, each and every CPRI contributing a number of role. Most of them think that power, they don't have an industry. The main industry for power engineering is CPRI, Central Power Research Institute. They are doing a wonderful kind of a research. Even in Bangalore, they're testing the towers, they're testing the lines, number of things they are doing it. Once you got a chance to make a visit to that, then you realize what is actually exactly happening in India. What are all the wonders happening in India, you can realize it. But these are all some of the things essential again to make it to introduce further. Now I'm moving on slide wise. The power system currently undergoes considerable change in operating requirement, mainly as a result of deregulation and due to an increasing amount of distributed energy resources. Therefore, here, because of the introduction of the deregulation, it is essential to increase by the way of distributed energy resources. Otherwise, distributed generations, using a distributed generation, that's called DG. In many cases, distributed energy resources, including different technologies that allow generation in small scales, that is micro sources, and some of them take advantage of renewable resources. Even they use some of the DGs as a renewable energy resources. We can form a DG as a non-traditional one, otherwise a traditional one. Which one acts as a traditional one as a DG? That's a question raises in front of you. That is a micro turbine. That is a traditional kind of a DGs. Even deeper, which one acts as a micro turbine? That is gas turbines that acts as a micro turbine. That may be the traditional kind of a DGs. That produce only even kilowatt levels. Once you produce a kilowatt level, your generating stations are located nearer to the load. That is called as a distributed generation. That's why it's named as a distributed generation. Once you locate the distribution generator nearer to the load station, what happened? Your transmission loss is eliminated. Otherwise, transmission loss is reduced. You can save a lot of power because of that. Even based on the calculation, the present transmission loss, that is equivalent to one big generator producing a megawatts. Such a kind of big generator. You can read such a kind of a thing. Today, 200 megawatt generator is installed in Neyveli. Today, 200 megawatt generator is installed as a nuclear plant and Kodangulam nuclear power plant. You read such a kind of a news. That is only, it is all in megawatts. But once we talk about a DG, it is only in kilowatts. Therefore, even you make this a kilowatt and megawatts, that is also possible. What is the way? You want to make it as a megawatt, for example, as a solar panels. You want to make it as a megawatt production. That's called as a solar park. You want to make it as a windmills as a megawatt production. How it is possible? You produce such a kind of a megawatts using windmills. That is called as a wind farm. What solar is called as a solar park, wind is called as a wind farm. That will produce wind farms and solar park that will produce in megawatts. That is also possible. Therefore, from that we understand nowadays it is essential most of the renewable energies to be act as a DGs. Why? It not only act as a production of a power, it is also act as a green energy. Very important message, it acts as a green energy. Nowadays, based on your theme of your faculty development program, it is essential to make everything as green. Then only you can avoid the global warming in future. Therefore, mostly in the DGs, you always prefer renewable energies as DGs. Once you prefer such a kind of a DGs, wonderful kind of things in the DG, the distributed energy generation is fuel cell. Fuel cell also act as a DG. It is also a green energy, very important message. Fuel cell works based on the electrochemical principle. It involves a number of electrochemical kind of materials. And even if it involves electrochemical kind of a principle, it acts as one of the green energy source. Fuel cell acts as a green energy source. Now the question is, what is the difference between a fuel cell and the storage system? Therefore, once you select any kind of a storage, battery may be act as a storage. That is always to be charged. Sometimes it is to be discharged. Whenever it is required, it is to be discharged. Otherwise, it is to be, after discharging again, it is to be charged. So then only it works perfectly. Any kind of a device that is to be charged, always it must be discharged. Then only such a kind of a device works perfectly. For example, in olden days, there is no power cut at all. Nowadays, there is a plenty of power cut. In those days, there is no power cut at all. At that time, most of the houses, they have emergency lamps that may not work perfectly. The reason is it is charged, continuously charging. They may not discharge at all. That's why it's not working perfect. But now the present day system, example is mobile. It works perfectly. What is the reason? You always charge perfectly as well as discharge perfectly. That's why the mobile works perfectly. Therefore, any kind of a device that is the batteries kind of a device is to be charged and discharged. Therefore, once you use such a kind of a things as a DGs, what then you compare even with a fuel cell. What is the difference? This kind of a battery source is always to be charged and discharged. But fuel cell, one, it works always based on the material. Once the materials are available, till then it works. The material not available, you may not get it. Okay, that is the difference between a fuel cell and a battery. Even the battery device, another kind of a device is that's called flywheel. Compared to the other kind of a device, what is the difference in the flywheel? It charges very fastly. Flywheel charges very fastly. That is the difference between the existing battery kind of the system with the flywheel. Therefore, even in the energy storage wise, we reached the latest technologies. What are all the latest technologies? Supercapacitor, magnetic energy storages, supercapacitors, lead oxide batteries, number of things. So latest kind of technologies appear. Compared to all other storage devices, even the supercapacitor produces megawatts. Very important message. Supercapacitor produces megawatt. In those days, in the fundamental wise, people are struggled to select which kind of energy is to be selected. Finally, in the olden days, they selected the base, electrical energy as a base. Remaining all energy is converted from that. What is the reason behind it? Because the reason is electrical energy can be easily transmittable. But remaining energy is not so. That's why they selected electrical energy. Remaining energy is to be converted from that. Therefore, they selected in such a way. But once you select in such a way, comparing with the present day kind of a storage, it is the storage. What is the disadvantage of that? It may not be easily storable. Even they selected electrical energy as a base, but disadvantage is it may not be stored easily. But now it is a scenario is completely changed. The storage kind of a technology also improved like anything. Okay. Therefore, once you look out that once, please kindly mute yourself. Somebody is not muting. Kindly mute your device. Kindly mute your device. Then only I can reach you. Otherwise, you are disturbing the whole presentation. Please kindly mute your device.
I request the participants to mute yourself. Participants, kindly cooperate with us to continue the session. Sudha Priya ma'am, kindly mute yourself. Thank you, Sudha Priya ma'am.
Now, continuation of that. The distributed energy resources. Now introduce a storage kind of device. Supercapacitors even produce a megawatt kind of energies. Therefore, it produces megawatt kind of energies. Therefore, we understand storage technology-wise, what all that research happened due to that. We reach even a wonderful kind of an achievement because of the finding out things of mainly because of these supercapacitors. Therefore, this may act as a DGs. This DGs are wonderful DGs. It meet out what your requirement very easily. Now I introduce a number of DGs to you. What is the way it is helpful to you in this presentation? That way I introduce to you. Next, the continuation of that renewable energy sources. You already know that you're familiar all this kind of a generating stations, that is wind, solar, tidal, geothermal, small hydro, biomass. You are familiarized all already, therefore it's not necessary to reintroduce to you. The continuation of that, having a micro source close to the load has the advantage of reducing transmission losses as well as preventing network congestion. Therefore, for reducing not only transmission losses because of the introduction of the DGs, and it is nearer to the load stations. Then what happened? This your generating station nearer to the load station. What happened? The transmission loss is reduced. Otherwise, it's eliminated. And because not only that, even the congestion also to be prevented. Now, the present day system based on the pre-power system restructuring. Once you introduce a pre-power system restructuring, what happens? Beating the power wise, people always prefer the shortest path to move on. Everybody prefers the same shortest transmission path. What happens? Congestion happens. Therefore, it is necessary to prevent a congestion. But once you move on to this kind of a DG kind of a thing, it becomes eliminated. Therefore, that is an important message. The possibility of having a power supply interruption of end customers connecting to a low voltage distribution grid is diminishing. Therefore, once you connect there is an interruption the end users, then what happens? You can easily now the present day system wise we're facing a number of problems due to low voltage and other kind of things. Once this kind of a way it is perfectly implemented, what happens? The other old kind of things automatically diminishes. Then the low voltage and other kind of things may not arises at all. From the utility viewpoint, application of distributed energy resources can potentially reduce the demand for distribution and transmission facility. Therefore, once you introduce distributed energy resources, what happened? It reduces the demand of distribution and transmission facility. And continuation, distributed generation, I already introduced. On-site generation, generating electricity from small energy sources close to the end users. The way even you can produce even a kilowatts. The way everybody become a 1 hour power producers, and you can't expect no more from the government to supply the power. You have to meter the power by yourself. If you belongs to a college, you have to meter the power. You have to erect all the solar panel on the rooftop of your college. You have to meter the power by yourself. That is the future. You can't expect the power no more from the government. DG technology yields a power and capacity that range from a fraction of a kilowatt to about 100 megawatt. Even you produce a kilowatt, that is also possible using a DG. Even you want a megawatt, that is also possible. I already give an example. You want to produce a megawatt, form a solar park. You want to produce a megawatt, form a wind farm. In contrast, the large scale generating station located far from load centers. DG system employs a numerous but small plants and can provide power on site with little reliance on the distribution and transmission grid. Therefore, they may not rely mostly on the distribution transmission grids, only rely on the DGs. If it is relying on the DGs, what happened? The large scale generating station located far from the load centers, that due to that, what all the problems arises, all it is to be eliminated. And the way it works, the system works in a pakka way. And not only that, it is green energy, low environmental impact. You prefer always the non-traditional kind of things. That is the renewable energies. And most of the renewable energies are green energies. Then once you prefer always the green energies, and instead of the thermal energy, even sacrificing the cost, we are in a position to sacrifice the thermal power plant. Then only carbon emission reduced. Tons and tons of carbon emission coming out of that. Through that, not only that it pollute. How to eliminate the carbon emission? That is also a big problem. Therefore, that arises. Therefore, the only ways to solve this, all thermal plant to be eliminated. Then only the problem solved. Previously, they concentrate on only two kind of greenhouse gas emissions, NOx and SOx. Nowadays, carbon emissions, CO2, that plays an important role. Because of that only the global warming, it happens. Therefore, it is essential to reduce, even sacrificing the costs of producing a thermal power plant to be completely eliminated. Always prefer a traditional, non-traditional kind or a renewable kind of energies, preferring a green energies. And due to that, we meet out our power requirement. Parallelly, the pollution is also avoided. And finally, it avoids the global warming. Well, that is what we expect. The environmental impacts plays a very important role. And microgrid, cluster of micro sources, loads an energy storage system that operates as a single controllable system. Okay, all together energy storage, whatever may be the micro sources you are selecting, it is to be operated with a single controllable system. And here the control system also plays a very important role, operating by connecting to the main grid or can be isolated from the main grid. Therefore, it is to be connected to the main grid or to be isolated from the main grid. Both the ways it's possible. Therefore, if your power is excess, you connect it with isolated power main grid. If it is any problem happens on the main grid, any fault, anything has happened, there's an abnormality, then isolate. That such a way also it can work. Not only one microgrid, even you can make it as multi-microgrid. That is also possible. Multiple dispersed generation sources. There is multiple dispersed generation is nothing but distributed generation. An ability to isolate the microgrid from the large network would provide highly reliable electric power system. Now the reliability is an important question in front of us. Till now, we are not bothering about the power system reliability. Now we are in an exact position to bother about the reliability, power system reliability. Why? Most of the power system erected is getting aged. Once it is getting aged, something to be repaired, something to be rectified, something to be remodified, something to be replaced. Number of things you have to do. Then only you can maintain the reliability. Otherwise, not possible because most of the power system erected is get aged. Once it gets aged, the reliability index goes on reducing. You want to improve the reliability, you have to concentrate on such things. In abroad, some of the ways they may not consider the reliability. Due to that, the blackout it happens. The blackout it happens in India, we can manage easily because without a power, how we manage, we know them. We are well experienced, but in abroad, very difficult to climb the steps where they require a power. Even cooking, they require a power. Without a power, we can cook easily, but without a power, they can't cook. All that devices based on the electrically. Therefore, they're facing even with the cooking and climbing the staircases, number of places they are facing a problem because most of the buildings are high-rise buildings. Therefore, blackout it happens, there's a big difficulty. That's why you have to maintain the reliability continuously, that too perfectly as a one index, the maximum as a one index. Therefore, once you maintain such an index, the reliability is maintained perfectly on the system. Microgrid supplies both electricity and heat to the customers by means of combined heat and power plant, micro turbine, fuel cells, photovoltaic system, wind turbines. Now here I'm introducing a combined heat and power. What do you mean by combined heat and power? Because you know them, everybody know them. Because the steam only most of the things produces the power. Therefore, it naturally requires a heat energy. Therefore, from that heat energy only steam it happens. But together with that, each exchanger add additionally, then the efficiency improved further. That's called combined heat and power plant. Together with the main power plant, you include some of the changes, then the efficiency of that plant is increased. But that is kind of a plant is called as a combined heat and power. Your plant is located nearer to the coal station. That plant is called as a pithead plant. Navy is one of the pithead plant because generating station and as well as a coal station, both are nearer. Then once the coal is found out, immediately through the conveyor belt, it reaches to the thermal plant. That's called pitted plant. Therefore, similarly, this is called as a combined heat and power plant. Therefore, you form such an heat exchanges. Combining the heat and power plant together, the efficiency is increased further. Therefore, due to that, your output also increases naturally. Continuation is challenges in microgrid. What are you want to design microgrid? What are the challenges in front of you? Protection of microgrid. Protection of microgrid plays a very important role. Therefore, automation to be changed completely. Once you have a Pakka automation, that microgrid works perfectly. Therefore, that is the main thing. Next one, stable operation during automation, where it is located. Most of the times, the main station, otherwise substations, the automation is located. There you have to give the appropriate protection. Stable operation during network disturbances. Therefore, always to be maintained the stability of the network. Any disturbance that happen beyond that is the stability to be maintained continuously. But that is anything to be happen immediately or to isolate, remaining things to be work continuously. And even the isolation restore at the earliest. That we are going on maintaining the stability operation during the network disturbance. What are all the disturbances that happen due to fault, over voltage? Number of ways that disturbance that happen. Otherwise, that's called abnormality. There is a two kind of studies in the power system. One is steady state analysis. Other one is a transient kind of analysis. Once abnormality to happen, the transient analysis is required. In the normal state, that's called steady state. That way also it's required. In both normality, abnormality, low flow analysis is essential. Therefore, but in the transient kind of analysis is required only at the time of transient conditions. But short circuit analysis is also required only at the abnormalities. But the low flow is required for both steady state as well as the transient state. Even in the research wise, now we find out the three-phase. Three-phase, why immediately you can ask why they are not going beyond that. Even beyond that, they find out 6-phase is a successful one. Even double circuit wise, 3-phase, we have a 6 conductors. Compared to that, instead of that, you select a 6-phase, that is also 6 conductor. Compared to that, 6-phase is more number of advantage. Why they didn't select that one? The reason is at this time, it is only tested on the steady state. They never tested on the transient state of a 6-phase. It may not be successful. That's why it may not be implemented at those days. Now the research is going on. Whenever it is to be successful, they prefer the 6-phase. Now I explain about stable operation during network disturbance. Control strategies for inverter to provide stable frequency and voltage increasing of various loads. Therefore, even you select a different kind of converters. Because of power electronics, there is a plenty of converters are now introduced. Cuck converters, is a matrix converters, number of latest converters. It is introduced. Therefore, loop converters, number of them even named by the scientist name. And other inverter-wise multi-level inverters. Number of them going on changing the levels. But there is a plenty of research is going on in that direction. And for all these inverters and converters, control strategy plays a very important role. And selecting such a kind of a control strategy, then only the power electronic devices works perfectly. And your control strategies are not good, it may not work perfectly. Therefore, that is also plays a role. Even beyond variation of the load, this control strategy is to be work appropriately. That's very important. Compared to the other kind of things, you introduce a renewable energy. Compared to the conventional kind of energies, renewable energies are highly variable. So you can incorporate with the main grid. Integration plays a very important role. Even it may be isolated grid. That way also is highly invariable at how you are going to maintain the frequency as well as the voltage. That's a big question mark in front of you. That's called integration. Integration plays a very important role in the microgrid. Next advantage. What are all the advantage? Improves local reliability. I already explained a lot of things about reliability. Even the local reliability also plays a very important role. Reduce emissions. Therefore, emission also reduced because of the introduction of this kind of a microgrid. In the microgrid, we introduce DGs. Once it is introduced the DGs, it reduces emissions. Therefore, because we prefer most of the DGs as non-traditional, otherwise renewables. Once you prefer such a kind of a thing, it acts as a green energy. Once you prefer, due to that, the reduction of emission, it happens. lower the cost of energy supply. Therefore, because of all this introduction, you think that the cost may be very high. It is not so. It is again that it's lower the cost of supply. That's an important message. Improves the power excellence by supporting voltage and reducing voltage dips. The quality also plays a very important role. To maintain the quality in both distribution and transmission level, we introduce the fax devices. And beyond all that, the power excellence by supporting the voltage, reducing the voltage dip is exactly the power quality. That is to be maintained appropriately, then only the system to be improved in a better way and in the best way. Reduce the transmission losses. I talked about the transmission loss also a lot. Improves the service quality. What do you mean by service quality? Not only power quality, service quality is very important. Your services for all this kind of things, and you are maintaining the quality of that service in a proper way. That way also you can improve a lot. The service quality plays a very important role. For example, your main boxes there, main switching box, the switch gear, other kind of things in the industries. Similarly, in a house, the main boxes, main is where it is located. People are going on dumping like anything. The waste kind of things, they are going on dumping nearer to the main switch, otherwise nearer to the switching stations. But that is to be avoided completely, because that is called one of the main things of maintaining the service quality. The maintenance of device is a very important message. That way, it's one of the examples of to maintain the service qualities. That is the way the service quality also to be maintained continuously, concentrating on the preventive maintenance. Which one is the better one to maintain your reliability? Always the preventive maintenance works in a pakka way. That works perfectly and make you the system works perfectly. And the introduction continues further, supplying AC and DC loads using DGs. Though only using DGs, even you can supply separate AC loads, separately for AC load, separately for DC load, both possible. To reduce the multiple reverse conversion in an individual AC or DC grid. The multiple reverse conversion in the individual AC and DC grid, that is also possible. You want to make AC to DC, DC to AC. Which one I'm going to introduce here is not only I'm using a main converters, there is a backup converters also I'm using it. Because of that, you can move on to AC to DC, DC to AC easily at any time. Therefore, there's two kind of a mode I'm planning to use here. One is grid tied mode, other one is isolated mode. I already explained. The grid tied mode, whenever there is an excess power, you can supply to the grid. Such a way you can use. For example, you use electrical vehicle. What happens? Once you supply to the grid, it's vehicle to grid. Once that's supply to the grid, it means discharging. Once you charge it, then what happens? Grid to vehicle. That is called as a grid to vehicle. Grid tied mode, this acts as a grid tied mode. The electric vehicles plays a very important role. Among all the DGs, electric vehicle is one of the best supply. What happened when we face a problem according to the load curve? The 24 hours load pattern curve, at the time of peak, only we struggle. You make the peak as off peak, all the problems are solved. Even a small kilowatts are enough to make the peak as off peak. That is supplied by the electric vehicles. Not only it supplies, it moves and supplies. Very important message is moves and supplies. It acts as electrical vehicular power system. It moves and supplies. Therefore, that is very important among all DGs. There is two kind of ways you can act the microgrid. One is grid tied mode, other one is islanded mode. Conversions are controlled coordinately to get maximum power from renewable power sources. You can get the maximum power from the renewable power sources. Always you extract the maximum power, maximum, maintaining the stable operation of the AC and DC grid. You always concentrate on the stability. That is also plays a very important role. And to provide the stable DC bus system, or the DC bus voltage also to be provided safely. It is all depends on what converters are controlled coordinatedly. Well means all these three maintained appropriately. Now I am introducing the hybrid AC-DC grid to you. Now have a look at the figure. AC microgrid looks like this. This is a diesel generator. Wind speed, the wind energy is given over here. That is doubly fed induction generators. Through that, wind generators are working, and that is supplied to the AC grid. Diesel generator also supply the AC to the AC grid. The next AC microgrid, that side. The other one is So the one based on a single kind of a concept, the wind energy, that is also supplied to the power to the AC grid. And next one is tidal, based on the tidal power. The power is supplied to the AC grid. Next, from here, there is an excess power. You want to supply to the utility grid or main grid. Then the breaker to be closed, supplied to the utility grid through this. And you want to meet out within this grid, then the load, what are all you generated, that is to be utilized in the AC loads, this side. But this side is totally called as a AC microgrid. The generation also AC and supplies to the AC load this side. Even it supplies to the DC side. That's very important. Now have a look at the DC microgrid side. DC microgrid, permanent magnet generators, synchronous generators. That is act as the main thing. That is AC to DC. That's supplied to the DC grid. Next, solar irradiation. The ones you select is solar irradiation. Because of that, not only it produces only a DG, but we use a booster to boost further, then supply to the DC grid. Most of the non-traditional kind of generations produce only a real power. You want to run the system, you require a reactive power also. For that, you use a power electronic device. The very important message. Therefore, you run the system because system is complex. It involves real and reactive. Real is directly proportional to the current. Reactive is directly proportional to the voltage. We require to run the system. We require a voltage and current. For example, there is a flow of water on the line. You require a force as well as a flow. Flow is a current, force is a voltage. Both are required to flow the water. Similarly, both are required to flow the electrons through the line. Therefore, from that we understand, once you produce the solar kind of thing, produce only real power, you have to manage the system with the reactive power. For that, use a power electronic device. Fuel cell stack, that is supplied directly to the DC load. Flywheels, that is also AC to DC convert and supplied to the DC grid. Next, battery, that is only produce DC. Using a converter, you can improve further and supply to the DC grid. And electric vehicle, that is DC plug-in electric vehicle. One is plugged in, then charged. Plugged out, it is discharged and supplied to the DC grid. And this side is all what are all produced as the DG supplied to the DC grid. Not only that, it meets out the DC load, right? And if it is in excess, it's supplied to the AC grid. Both ways possible. For that, we use this main converter, bidirectional AC-DC converter. Once the power is excess in the DC side, what happens? This acts as an inverter. Once this side is excess, what happens? This converter acts as a converter. And not only one thing, we have a backup converters. If this converter is not working properly, we have to use this backup and work continuously. That is called as the AC, hybrid AC-DC microgrid. I've shown the whole picture through this diagram. Now the configuration of hybrid AC-DC microgrid. This is using a solar irradiation panels, using a boost converters and select a battery converter. Battery and together with the converters and supplied to the main grid, and then it is supplied to this AC side, wind side. Otherwise, there is an excess power. From here, it is supplied to the DC. For example, solar may not be available continuously. What happened? It's battery supplies. Through the battery, you can meet out the DC load. Similarly, here the wind works on wind dynamics. It may not be available throughout. The wind always may not be included in the power demand because it's not predictable. It depends on the wind dynamics. Therefore, the wind is not working. What happened? We can supply through the battery devices to this, through this converter, and supply to the AC grid. If there is an excess power, then even you can supply to the utility grid. That is also possible. Otherwise, you want to meet only the AC load, you can meet out the AC load. That is also possible. That is the way the configuration is shown. But till now I explained configuration of the hybrid AC-DC microgrid. The text-wise, DC power source such as photovoltaic panels or fuel cells are connected to the DC grid through DC-DC converters. Therefore, that is a way I've shown already explained on the diagram. Even we can connect with a fuel cell. That is a way also you can connect. DC loads such as electric vehicles, speed control motors are connected to the DC side. That is, you can connect with the electrical vehicle to the DC side. That also has shown. DC energy storage system. Supercapacitors are connected to the DC bidirectional converter. Use supercapacitors. The DC energy, DC grid side. AC source such as wind turbine generator diesel generator are connected to the AC grid. But this to be connected to the AC side. AC loads are used to tied to the AC grid. You want to meter only the AC load, that is to be tied to the AC grid. You want to meter only to the DC load, that is to be tied to the DC grid. AC energy storage such as flywheels are connected to the AC grid through AC converter and transformers. Therefore, flywheels are also connected in the AC grid. Otherwise, even in the DC side, as shown by the figure-wise DC side, AC to be converted to DC and supplied. AC grid and DC grid connected together by means of bidirectional main converters. The implementation continues. PV models are controlled to extract maximum power. The PV models are controlled to extract maximum power. Therefore, you want to track the maximum power. That is very important. To track the maximum power, it is essential. Which one is essential? Maximum power point tracking algorithm is essential. There is a different kind of maximum power point tracking algorithm. One is the incremental conductance algorithm. The one is a per turn absorb algorithm. Next one is fuzzy logic based controller. Next, parasitic capacitance control. But the different kind of algorithm plays very important. In our problem, we selected the incremental conductance algorithm. First one. Okay. The converters are coordinately controlled for smooth power exchange between AC and DC grid. Because of this controllable coordinations, there is a smooth power exchange between AC and DC side. If output power from the DC source is greater than DC load, what happened? The main converter acts as inverter. So if it is DC source is greater than the DC load, main converter acts as inverter. If output power from the DC source is less than the DC load, what happened? Main converter injects power from AC to DC. Therefore, it acts as a converter. So main converter, when it is acts as inverter, when it is acts as a converter, be explained here. Now the incremental conductance algorithm. The incremental conductance algorithm, IC algorithm, is used to determine the variation direction of the terminal voltage of the PV model by measuring and comparing the incremental conductance, GD, and instantaneous conductance of the PV model. Therefore, when you get the maximum power, have a look at this figure. Once the incremental conductance equal to the instantaneous, only at this point, incremental conductance equal to the instantaneous. There you can extract the maximum power. Here, from here to here, the GD is greater than GS. From here to here, GD is greater than GS. From here to here, GD is less than GS. Incremental conductance greater than the instantaneous conductance. Here, the incremental conductance less than the instantaneous conductance. This curve, this linear wise changes based on this. But at this point, you can extract the maximum power. What is the condition? Incremental conductance equal to the instantaneous conductance. Now we have the proof of this. We have a look at the proof of this incremental conductance algorithm. When the operating point of the PV model is it in current region, then the slope of the power curve is positive. Therefore, the operating point of the PV model is in constant current region. Then what happened? The slope of the curve is positive. dP by dV is greater than 0. When the operating point of the PV model is beyond the maximum power point, then the slope of the curve is negative. Beyond the maximum power point, what happened? The slope of the curve is negative. dP by dV is less than 0. Okay. When the operating point of the PV model is exactly on the MPP, on the maximum power point triangle, then the slope of the power curve is equal to 0. When the power point of the PV model is exactly under MPP, then the slope of the power curve is equal to 0. That you mathematically understand very easily. Once you differentiate the power with respect to voltage, equate it to 0, you can easily get the maximum. That is the principle of mathematics. You want to find out the mathematical derivative to be equated to 0. That's through that only you can get the maximum. Therefore, when you get it, instantaneous conductance equal to the incremental conductance. At that point, dP by dV equal to 0. There you can extract the power maximum. What are all the three kind of concepts now I explain? Have a look at this again on the figure. Now this is the point. First point is here, GD is greater than GS. Second point is GD equal to, second point is GD greater less than GS. this point. Third point is GD equal to GS. The instantaneous conductance, incremental conductance is greater than GS instantaneous conductance here. Incremental conductance equal to instantaneous conductance here. Incremental conductance less than the instantaneous conductance here. Therefore, only at this point the maximum power is tracking it happens. So once you find out the maxima, at that point only you get the equalities of this instantaneous conductance with the incremental. That's what I explained there. Now, based on this explanation, what happened? This can be expressed as dP by dV. Now we are differentiating power with respect to voltage. Instead of power, if it is DC, now I am substituting VI. Differentiate what happened? I plus V into di by dV. After differentiation, you get I plus V into di by dV. But max, you want to get the maximum, what to do? dP by dV equated to 0. This is to be equated to 0. Then this is equated to 0. What happened? You may modify what happened? Di by dV equal to minus I by V. You get finally di by dV equal to minus I. This is called as incremental conductance. Therefore, di by dV, I is differentiated with respect to the voltage. That's make it as a small increment, rate of change using the differentiation. That is called as incremental conductance. But minus I by V, exactly it is to be specified in terms of small letter. Minus small I by V, that is called as an instantaneous conductance. This is not V by I by V. That's why you can get the conductance. That too, only I by V. That's why it's called instantaneous. That too, small letters. That's why it's called as instantaneous conductance. This is a rate of change. Otherwise, the small increment. That's called as the incremental conductance. So at this point, GD equal to GS. In the incremental conductance is equal to the instantaneous conductor. That's why you get the maximum power. Now I proved it through this. If the operating point on the left side of the curve, then di by dB, it is equated to minus I by V. Otherwise, GD greater than GS, dB by dV greater than 0. If the operating point is on the right side of the curve, then di by dV is less than minus I by V. Otherwise, GD is less than GS, dP by dV is less than 0. That is the way it acts. Again, do you want to recall? Have a look at this figure. At this point, GD is GD greater than GS. At this curve, GD less than GS. At this point, GD equal to GS. Only at this point you can get the maximum power tracking. Here the graph is drawn for I versus V. I versus V. That's the way it's drawn. Now moving on to the next slide, power versus voltage curve. For the power versus voltage curve of a PV model at different radiation level. Now I'm showing the different radiation level. 200 is one other radiation level, 400 another one, 600, 800, 1000. Different radiation level, we get a different PV curves, power and voltage curves. Okay. Now once you base on the radiation you decide means appropriate power curve to be selected. Based on that you can find out your different irradiation levels. Once the radiation levels are decided proportionally, what is the value of the power you require, that is also decided. Now, till now, what we are talking about the incremental conductance algorithm, that same incremental conductance algorithm explained by the flowchart. Start, measure V of n, I of n, Vn minus 1, In minus 1. What do you mean by that? Vn is a present value, Vn minus 1 is the previous value. I of n is the present value, In minus 1 is the previous value. Now, di is a present value minus the previous value gives a di. dV is the present value minus the previous value gives a dV. di by dV. Now I explain. dV equal to 0. When once it is dV equal to 0, there's two ways to go. No means connected to A. Yes means connected to B. Now connected to A. No means connected to A. Then what happened? di by dV again it check another checking box equal to minus I by V. If it is yes, directly connect to the last one. Otherwise, no. Coming further, di by dV greater than minus I by V. Check again. If it is yes, VR equal to VR plus small increment is added with that. You get the new VR. If it is no, VR, the small increment is subtracted. You get the new VR. That is the way two values you get. If it is B side, what happened? di equal to 0. If it is di equal to 0, yes, it goes then. If it is no, it comes to this side. Di greater than 0, then if it is yes, what happened? Vr together with small increment is added. No, Vr is subtracted from the small increment. It is vice versa. It is different than this. Then it comes to the final one. Final values, updated voltage and current, it appears. Vn-1, In-1. And it updated as Vn-1 act as a new V of n. In-1 acts as a new In. Because that way it will return back to the main algorithm. So now, what is the way the control it happened in on my present presentation, present microgrid? The MPPT is act as a controller. The input given to the MPPT is a voltage sensor and current sensors. Through the solar panel, you get the value of voltage current sensors that is given to the MPPT. Then through the MPPT controller, it supplies the DC-DC power converter. Through that, finally, after controlling, it finally comes out and meet out the load. This is called as the implementation of MPPT with boost converters. The operation of the hybrid microgrid. But now I've shown the figure how this hybrid microgrid works. Hybrid microgrid can operate in two modes. One is grid connected mode, grid tied mode. Other one is islanded mode, otherwise autonomous mode. It works. In grid tied mode, the AC grid is connected to the utility grid. Okay. In the grid tied mode, AC grid is connected to the utility grid. During fault in the utility grid, microgrid operates in the isolated. I already told you. If it is abnormal system, abnormal kind of a thing, it happens. Then it is during that period, the utility grid, the microgrid operated in the islanded mode. That is one. At that time, microgrid operated as islanded mode. The AC grid is connected to the utility grid when it is only if it is a grid tied mode. Main converter is controlled to smooth power exchange between AC and DC. Based on the main converter's control only, the smooth power exchange happens between AC and DC grid. PQ controller or troop controller. There is two kind of controllers you can use. PQ controller or troop controller can be used to control the main converter. The real and reactive power exchange is controlled with the help of PI controller. Only you want to make a change on the real and reactive power, through the PI controllers, you can make a change. During the islanded mode, energy storage system operates at energy buffers for balancing the power surplus and shortage. Therefore, which one acts as a buffer? Energy storage. That acts as energy buffers. Once it acts as a buffers, shortage or surplus, both of it may be very helpful and maintain the system stability under variation of load condition. Even there is plenty of variation. Beyond that, you can maintain your system very well. Main converter use main grid electrical signal as references. Therefore, once the main converter, you select the main grid electrical signals as the references, that way it acts. To control active power through DC bus, VDC is compared with the reference. Therefore, always VDC also works. It's always comparing with the references. The DC bus voltage error feeds a PI controller having current references output. Any bus voltage change error, it happens through the PI controller. You can make a control on that. And the Q-axis current is set by Q-axis voltage controller to control the reactive power flow. Based on the Q-axis, till now we are talking about the P-axis, now Q-axis. Current is set by Q-axis voltage controller to convert the reactive power flow. And D-axis current is set by DC bus voltage controller, control the reactive power flow. Here, through the D-axis is control the real power. Through the Q-axis, control the reactive power. The D-axis current is set by DC voltage, control to control the active power flow between AC bus and DC bus. And now almost we come to the concluding part of this. And the architecture, operation, and control of the hybrid AC-DC microgrid has been discussed till now. That is, till now I have shown the architecture as well as how it operates, how it controls, all I explained. The hybrid grid may be feasible for small isolated industrial plants. What do you mean by feasible? The feasible word is very important. It works on all kind of a constraint. It satisfies all the kind of constraint that's called as a feasible. If it is not satisfy the constraints, it's not feasible. Similarly, the controller, they say always robust controller. Why it is called as a robust? That must work on normal and abnormality. Both the way it works perfectly, then only it's called as a robust control. Otherwise, it may not be. Similarly, the feasibility, it satisfies all the kind of constraints, then only it's called as a feasible system. Otherwise, may not be. For small isolated industrial plant, educational institutions or commercial building with the help of distributed generation as major power supply with the following advantage. Therefore, based on the major power supply, the following disadvantages it happens. One is improved local reliability. It improves the local reliability. I explained a lot on the reliability. Reliability plays a very important role in future because most of them get aged. Some of the things to be repaired, some of them to be replaced, and some of them to be repaired. It is essential to maintain the reliability. That too, as a maximum as 1 index. Reduce emission. It not only improve the reliability, it reduces emission. Most of the supply is based on the non-traditional kind of things, otherwise renewable energy kind of. That's why it's reduced emission. It acts as a green energy. Low cost of energy supply. Even beyond all this energy cost, supply cost is less. That's why the low cost is maintained continuously. Reduce the transmission loss. It reduces the transmission loss. That's very important. And now I told you because of the introduction of the DGs, the transmission loss may be eliminated, otherwise even reduces further. In such a way, it's essential to reduce the transmission loss. Improve service quality. The service quality is also to be improved throughout. Making a preventive maintenance, otherwise maintaining appropriately, improve the service quality. Next, improve the power quality. And supplying the real and reactive compensation wise, it may be used factory devices. Through that, improve the dip of the voltage and improve all kind of ways to maintain the quality. And higher order harmonics to be nullified and only maintain lower order harmonics. That way you are improving the qualities. And the qualities plays a very important level, important in the distribution as well as in the transmission levels. Once you maintain quality appropriately, then your system maybe works in a Paka way. I think so. We come to an end. Thank you for your patience. My presentation is not so important. What are all the queries in your mind you can raise? It may be beyond this subject. Based on the queries only, you can gain a lot. You can gain a lot. Now it is open for queries.
Thank you, sir. Thank you for your detailed presentation on hybrid AC-DC microgrid architecture, operation and control. It was very informative session, sir. Thank you. Now it's a query session. We request the participants to ask. If you have any queries, you please ask, sir. Participants, now you can unmute yourself and you can ask your queries.
Hello, sir. Hello, sir.
Yes, sir. Please.
Yeah,
Yes, sir.
I have a query. What is the extent of scope of IoT in microgrid operation?
Repeat the question.
What is the scope of IoT in microgrid operation?
IoT is nothing but making a coordination. Therefore, through the IoT, you can easily make the coordination throughout wherever the microgrids are available. Because nowadays, the present day system not only stops with the microgrid, there is a multi-microgrid. Therefore, wherever there is a microgrid, you can easily coordinate all the microgrid. Otherwise, you make this is a grid. It is grid connected mode. All the grid microgrid, how it is to be connected, the grid connected mode. There, the IoT plays a very important role. Through the IoT, you get all kind of informations, and you based on that you can improve further, right?
Okay. Thank you, sir.
Any other queries? Our expectation can be utilized only by the queries, not based on the presentation. Most of them may not listen to the presentation. Based on the queries only, I can reach you. And there is a plenty of audience, 134 plus. Means I think so around 150, it seems that, around 150. Therefore, the participants are very high. The query is also to be more. I think so most of them sleeping. You can raise your queries, then only the session may be interesting.
Participants,
They
you
give
can
a
also
2
type.
hours or 3 hours. They give a 2 hour, 3 hour presentation. It may not be useful. You can spend with us for half an hour query, then only it's useful. Compared to presentation, query is very important.
Dear participants, you can type your query on the chat too if you are not able to connect with us. We will help you to clarify. Participants, if you have any query, you can type it in chat box too.
Okay, ma'am.
Sir, one participant asked the question that what is the max grid capacity in India?
What is the maps?
Grid capacity in India. It's asked by G.
Map
Uma Shankar. Maximum grid capacity in India.
Maximum grid capacity. Right. So now maybe it is around 12,000 megawatts. Such a level the grid are facing. Now in India, what they are planning means they make the grid as a nationalized grid. Therefore, there is a southern grid, northern grid, such a kind of grids are now what is available. They make it all this grid together, make it as a nationalized grid. Once it is a nationalized grid, it's similarly like nationalizing the river. There is a river, once it's nationalized, what happens? There is an excess water available. Some places the water may not be available. They supply from the excess water. Similarly, the energy wise, where there is an excess energy, where the energy may not be available, it's supplied easily because you make the grid as a nationalized one. But such a way it is to be nationalized. For that, now the capacity is shown by the grid wise, southern grid, northern grid, like that. Now, once it is nationalized, it is all to be the capacity of the grid to be talked in terms of the whole India.
Thank you, sir. Next question asked by Vijay Lakshmi Saka. The question is how to realize PLL. We'll request the participants to mute yourself. Those who have the questions, please unmute. Sir, the question is how to realize a PLL when implementing hardware of grid tie inverter.
How to realize a PLL. PLL means, I think so, what they mean as a PLL.
I think
please
phase locked loop, I think so.
Phase locked loop. Oh, right. So to realize a phase locked loop when implementing the hardware of a grid tied inverter. Once it is phase locked, therefore, again, it is to be acted with what are all the phases available within that. At that time, again, through the hardware, you make a control on the grid. Therefore, there is a separate paper is published on that. That gives a more clear picture on that. I have not much idea on the phase locking. Okay, therefore that I have seen such a paper on the net. Please try to find out the answer on through that paper.
So next question asked by Vijay Lakshmi Shakar. What are the problems which may occur during synchronization of power grid?
Yeah, one very important question. That is a nice question also. Those who studied power engineering as a master's degree, you know them. Where the bidirectional flow of the power, it happens only the one region to the other region. That plays a transmission called as a tie line transmission. With the tie line transmission, the flow is you gave the power or take the power. Both it happen bidirectionally. Once you do such a way, synchronization plays a very important role. What is the way it is to be synchronized? That's at that side area is generated, this side area is generated, frequency to be matched. The frequency is not matched, then the synchronization may not happen. You have to maintain the frequency continuously. For example, according to the standards of the Indian frequency wise, it starts from the 49 to 50.05. That is a standard of Indian maintaining the frequency throughout in India. Therefore, in abroad, particularly US, the frequency itself differs. That is 60 hertz. In India, 50 hertz. That to start from 49 to 50.5, it is allowed. If it is a voltage violation, plus or minus 5, but here the frequency it is not so. 49 to 50 point. That is to be monitored continuously. You want to maintain the frequency continuously. That way, you can synchronize one area with other area very, very easily.
Thank you, sir. The another one, Ramji Prasad Gupta asked the next question. Is there any standard value of voltage generated and frequency in case of wind generation in India?
Is that?
Any standard value of voltage generated and frequency in case of wind generation in India?
Yeah, so you want to know the standards means the people are always continuously releasing the standards. In this service is done by IEEE for all over the world. They each and every day they're going on releasing the standards. Once you have a look up the standards, you know the standard values. Similarly, in India, for the electricity power authorities in central government, they are going on releasing the standards. Therefore, now your question is standard value of the voltage generator and frequency in case of wind generator. Therefore, that is you asking about the data. Therefore, you have to raise some of the queries to me. The data wise, all data are available on the net. You can search the data in the India wise. What is the wind and generating voltage generator level and the frequency? Naturally, the frequencies it may not go to beyond 50. What are now I told you 49.40 starting from 40, 50.05. That is a standard. That is a standard Indian standard. Similarly, the voltage generated wise, therefore we always say voltage plus or minus not the per unit value wise start from 0.95 to 1.05. That is a standard. Whatever may be the value, the voltage how it is to be maintained as a standard 0.95 to 1.05. That is a standard to maintain the voltage per unit wise. Therefore, whatever may be the value, this standard to be strictly followed. These two are Indian norms, right? This two to be satisfied. You want to know the exact value in appropriate place that is available on the net.
Thank you, sir. Thank you for your answer. Next question asked by Manjappa N. The question is, what are the issues and challenges we face if we go for microgrid?
Yeah, once we go for the microgrid, I already told you the challenges in front of you is integration. Once you main grid, it is connected to the main grid, integration. Because renewable energy sources are highly variable. That is to be connected to the main grid, the integration, how the voltage and frequency to be matched with the main grid, that is plays a very important. That is a challenge in front of you. You have to work on the integration. There is plenty of papers already appears on the research wise how this integration to make it as a successful one. There's a plenty of ideas also available based on that. Similarly, the other one is if it is isolated mode, therefore you have to maintain the voltage, everything you can.
Dear faculty participants, please mute yourself.
Therefore, the second one is such a way that is to be
participants we are getting.
Before the microgrid wise, once the issues in the challenges, I already, the ones I explained with a grid connected mode. Similarly, the isolated mode. Once it is isolated mode, all how to maintain the voltage, frequency, everything to be checked out by yourself. No one help you. That is also a big problem. It is not so easy to do it. That is also another challenge.
Sir, thank you, sir. Thank you for your answer. The next question is asked by L. Chitra. The question is, do we have to consider time synchronization in smart grid?
Time synchronization in smart grid.
Smart
grid. Yeah, time synchronization is what do you mean by that? There's nothing but frequency. Once you maintain the frequency, time automatically comes. I think so. You may not understand the frequency.
Thank you for your answer, sir. The next question is asked by Ashish Kumar Srivatsava. How Scada data can be used for prediction for planning a microgrid using machine learning techniques?
Yeah, the Scada is, once you use a Scada, it may be useful, it gives the data from remote places. Once you start to use a Scada, it gives going on supplying the data from the remote places. That way it may be very helpful. Anything happen on the remote place, how to be nullified or to be restored, only by the way of through getting the data. That is through Scada. There is no doubt about it. And finally, they're adding Scada.
Machine learning techniques.
Machine learning, right. Therefore, once it goes on receiving the data, that is machine learning is nothing but a data set. Once you receive all the kind of data, that based on the data, you give a restoration plan very easily. That is called as a machine learning. Therefore, once through the Scada, you receive all the data. That's called data science. Once you receive such a kind of a big data, and continuously, and based on the data, you're going on giving the solution in a perfect way. That is machine learning. Even use any kind of intelligent techniques, deep learning, whatever may be the technique, you can use it. Then using that technique, you can further to be what are all the kind of things to be optimized, what are the kind of things to be maximized. Everything you can do using a machine learning kind of a techniques.
Sir, thank you for your answer, sir. Dear participants, okay, sir, another question, sir, asked by Ashish Kumar Srivatsava. Open source data can be creditable for such analysis.
Open source data, right? The open source data means there is a two kind of data, power system wise. For example, you want to produce any kind of a product, that standard data are different. But in the power system wise, there is a two data. One is the standard data. They supply the IEEE 14 bus system like that. You have seen number of, that's called standard data. Other one is utility data. That's called the practical data. Therefore, first we always your new kind of a research to be tested on the standard data, IEEE data. The way it works for the standard data, then come to the utility data, otherwise practical data. Once you apply for the practical data, then because you're already successful in the standard data, then again you use it for utility data, that is also successful, then your research or your contribution, your work is perfect. But that is the way the data are very helpful. Therefore, the standard data are going on released by the IEEE people for the standard data. Practical data you can get anywhere. And even in the paper-wise, there is plenty of practical data also available.
Thank you for your answer, sir. The next question is asked by Vijay Lakshmi Shakar. Any works done by artificial intelligence?
Any work?
Done by artificial intelligence.
Yeah, artificial intelligence is different from artificial intelligence technique. Always minded. Artificial intelligence technique using any kind of a computational intelligence technique or soft computing, all are one and the same. The word that is to be utilized for mimic. For example, first neural networks mimics in a way. Fuzzy logic acts as a good controller, and remaining most of the techniques works as a good optimization tool. But these are all called as a intelligent kind of a techniques. Artificial intelligence or computation intelligence or soft computing, even natural computing. These are all called as a algorithm-based kind of a thing. Using a flowchart based on the nature-wise, the flowchart is formed as an algorithm, we can solve it. But artificial intelligence is entirely different. How the artificial intelligence it comes. Therefore, you make an expertise of any kind of a system. Whatever you ask, like a human being, it answers immediately. You make an expertise, then it is called as artificial intelligence. For example, you can read out that artificial intelligence. They give a two kind of a programming. There's a programming wise, it's called as C programming. You know them. You want to talk with a computer, always ask my student, what is the kind of a language you prefer? Most of them struggle. I'll ask, you can talk with C++, you can talk with Fortran, you can talk with BASIC. It is not so. These are all almost English. You remove the almost, directly talk with in English. That is the requirement. Therefore, once you talk in English, it immediately convert and invert, whatever may encode and decode. Immediately it will give you the solution. That is the best way. That is called artificial intelligence. Therefore, at that time, there is no almost English. There is such a two kind of a program initially introduced long back. Lisp and Prolog. Once you have a look up the Lisp and Prolog, the programming looks like a paragraph. It is almost reaching nearer to the English. It is not like a single statement. Instead of that, it looks like a paragraph, Lisp and Prolog. And finally, the Lisp Prolog also nullified or eliminated. You can directly talk with the computer, immediately give the solution. That's called artificial intelligence. Your intelligence is created artificially. That is artificial intelligence. That is entirely different. Therefore, you can use such a kind of a ways in your work. The artificial intelligence to be applied to the smart grid. What is the way? It automatically solves the problem, self-healing. It solves all the problem by themselves. That's called artificial intelligence. Okay, almost the smart grid is aiming like that. The main aim of smart grid is self-healing. You using an artificial intelligence technique only, you can make a pakka self-healing process. Otherwise, not possible. Right.
Thank you, sir.
Thank you, sir.
for the clarification, sir. Dear participants, if you have any queries, please ask.
Now, based on the query only, I think so you gained a lot, right? Because you never ask queries. What are all now I told you may not reach you.
The next question, sir. Participants, please mute yourself. Thank you. So next question asked by A.V. Pavan Kumar. Will there be smart substations for microgrid implementations?
Will there be
Smart substations for microgrid implementation?
Yeah, so there is no question of requiring a smart substation. You want to form a microgrid, that itself required a good automation. I already explained protection. In one of my slides, I explained. Okay, you require a good automation. That's called protection. The substation is nothing but a protecting station. Therefore, you make it as a good automation. Automation means what do you mean? But automatically everything works. That's called smart. Therefore, you want to work this microgrid in a Pakka way, you require automation, a Pakka automation. That is nothing but a smart substation. Therefore, you really want to finally to achieve a smart grid, all to be smart. Once you make it, everything works in a Pakka way. Therefore, we can reach such a kind of a thing soon. It is not an easy task. It is really a difficult task in front of us.
Thank you for your answer, sir. The next question is asked by Ranu Nayak. The question is there any difference between islanded and autonomous microgrid? Sir?
Really answer, okay. Oh, you mean islanded? Not, one and the same. One and the same. Islanded and autonomous is one and the same. There is no difference at all.
Okay. So the next question asked by L. Chitra. The question is the difference between AI, MI, and deep learning.
AI, MI,
Deep
and
learning.
deep learning. Yeah. Artificial intelligence, I already explained. Okay. Artificial intelligence, I already explained. Okay. The deep learning is you make it, the learning as going on very deeply and as well as in depth, right? Okay. And the machine learning is, I already told you, get a data science. So once you get a data science, for example, I'm giving you the conventional kind of a machine learning. Without a driver, the car can be run. For that, you require plenty of data. Then only it works in a perfect way. It is nothing but a software. Without a driver, with a software, we can run the vehicle. For that, you require plenty of data. The moment of the angle, when any obstacle comes, how to be prevented. If it is a turning comes, how to turn the car. Number of informations are required. Which degree it is to be turned, like that. All information to be given as a data. We give such a big data and run this car without a driver. It is one example of a conventional kind of a machine learning. Therefore, for that, you can use even any kind of intelligent approach also. Therefore, all the artificial intelligence I already explained, machine learning through that I am explaining, using for this two artificial intelligence, machine learning, you require a tool. One tool is deep learning, right? That's all.
Thank you, sir. Sir, the next question asked by El Chitra, that is AI or ML better? Which one is better, AI or ML?
Now we are in the machine learning process. We are not realizing the artificial intelligence completely. Therefore, when we move on to the artificial intelligence next stage, then only we know all the answers.
Thank you, sir. Thank you for your answer, sir. Dear participants, if you have any queries, you can unmute yourself and you can ask your query.
Sir, can you provide your mail IDs?
Yeah, Kumarappan, Kumarappan, Kumarappan .IEEE @gmail.com. All small letters.
Dear participants, I have typed his mail ID on the chat box. If you want, you can take it.
Ma'am, I'm not able to see the chat box.
Okay, ma'am. I will write his mail ID on the chat box. Sorry, in the WhatsApp, ma'am. Ma'am,
Thank you, sir.
you no need to worry. I'll give you his ID. Yes, thank you.
Madam, kindly you please share the lecture video recording so that we can go through it once again before the tomorrow class.
Sure, sir. We will give you, sir. We will give you. Sure,
Please
sir.
kindly, madam, because so many things it's not possible. If we do see the video once again, it will be better for us, madam.
Sure, sir. Surely we will give you, sir. Thank you. Thank you, all the participants. Thank you, sir.
And thank you. It's a wonderful session because there is a number of questions raised. Thank you all.
Thank you, sir. Thank you so much. Thank you.
Ma'am, send the feedback also to me. Send the feedback.
Sure, sir. I'll share with you, sir. I'll share with you.
Thank you.
Thank you so much, sir.
Thank you.
Share the feedback with me too. I'm not able to see the chat box.
Okay, ma'am. Surely a problem will be rectified, ma'am. I'll give you the feedback link.
Thanks a lot, ma'am.
Okay, ma'am. Thank you.
Thank you. Thank you. Thank Elango is there? Elango, thank you. Thank you.
Yes, sir.
Thank you.
Thank you. Thank you very much, sir.
Excuse me, madam.
Yes, sir.
Ma'am, I cannot see the chat box actually.
Sorry, sir. I can't get you, sir. Sir.
I cannot get the feedback link because I cannot see the chat box.
Okay,
Basically.
sir. We will share with you, sir. We will share with you. Thank you.
Okay.
Dear participants, once again, I have posted the feedback link on the chat box. Please use it and send your feedback. Thank you. I thank all the participants for joining with us today. And tomorrow, the session will start at 9 o'clock in the morning. Thank you.
Excuse me, madam. Madam, actually, I cannot see the chat box in my MS Teams.
Okay, sir. Can you do that? Can you rejoin the meeting again, sir? You will get your message.
I have tried twice already, but it's not happening.
So did you join through the laptop or mobile, sir?
Mobile. I have joined through mobile.
Can you join through the laptop, sir, or desktop? Is it possible, sir?
Okay, if possible, can you please send a feedback link in my email ID if possible?
Well, sir, I will inquire with the coordinator and then I will send it to you, sir.
My email ID, maybe you can see it.
Yes, sir, we have. I have noted your name, sir.
Okay, okay. Sure.
Thank you.
Okay.
Thank you.
Ma'am, the same problem prevails with me.
Ma'am, excuse
Otherwise,
me, ma'am.
laptop, I'm not able to join through my official.
Okay, Rai, ma'am. I'll discuss with the coordinator and then I will give you a reply, ma'am. If possible, we will send you the link too.
Ma'am, there is some issues in sending the link privately to your WhatsApp or otherwise to the mail. So kindly refresh yourself or go back and come again, log in again so that you can able to see the chat box, ma'am.
I'm trying, ma'am.
Yeah, but morning we received more than 150 feedbacks, ma'am. The people's unable to access. So kindly, please use your laptop or desktop, refresh yourself, or otherwise you just go back and again log in again. Sure, you can able to get the chat box. Means the chat box. You can able to access the chat box.
Those who have submitted the feedback can leave the meeting. We will join tomorrow at 9 o'clock in the morning. Thank you. Balaji, sir. Balaji, sir. Balaji, sir.
Yes, ma'am.
Sir, did you
Yes,
see
ma'am.
the count? Did you see the count in feedback session too, sir?
Just a minute. Up to now, one